Now moving towards next, that is cofactor of determinant. So what is cofactor? Cofactor means it is same like minors, but the only difference is it contains a positive or negative sign as per their position, or in simple terms we can say it will be represented by aij, that is equals to -1 to the power I plus j mij. It is, suppose a matrix is given, we can take a matrix for 2 by 2 A, B, C, D. If we have to find first the minors of this, so we get M11, that is D, M12, that is B, M21, that is C, and M22, that is A. Okay, now if we have to find that the cofactors for this matrix, so what we can write? A11, we can write -1 to the power 1 plus 1 and M11. 1 plus 1 2, -1 to the power 2, that is 1 into M11 means D. So it is A12 means -1 to the power 1 plus 2 and M12. 2 plus 1 3, -1 to the power 3, that is minus M12 matlab means B, that is minus B. Then A21 means -1 to the power 2 plus 1 M21. 2 plus 1 3, -1 to the power 3, that is -1 into M21, that is C, so we can write minus C. And at last we get A22. A22 means -1 to the power 2 plus 2 and M to the power 2. -1 to the power 4, that is 1 into M22, that is A, equals to A. So these are the required cofactors. If we need to write this in a determinant form, so what we can write? A11 means D, A12, that is minus B, A21 minus C, and at last A22, that is A. So this is the cofactor of the given matrix. Is clear? And the last thing, the transpose of cofactor is known as adjoint of matrix, or we can say determinant. Okay, here cofactor matrix is this. If we transpose this, let's take it is represented by we can say B. So we can say B dash is equal to, if we transpose this, transpose means interchange of rows and columns. Here this is the row and it will become the column, and this is the row minus C. This will considered as adjoint of A. Clear? So it is now, I hope it is clear to all of you. So we can recall what we have covered till now. What is determinant? Determinant is a unique value of a square matrix. Determinant is a unique value which associates a square matrix. After that we had learned about the minor. What is the minor? Minor is the small part of the determinant. Cofactor is the place value of that values. Means her value की place value as per their sign. Alternate positive or negative, or we can say we can just substitute the value, whatever be the value we find, we just substitute in the determinant. And the determinant which we found after finding the cofactors, that is cofactor of determinant. And if we transpose this determinant, we get the adjoint of that determinant. I hope it is clear to all of you. Now please pause the video to note it down. Okay, now moving towards next topic, that is inverse of matrix. Okay, inverse of matrix we can find basically of two methods. One method is elementary transformation, which we already learned in our previous chapter. Now we are going to learn second method, that is adjoint, or we can say inverse with the help of adjoint. Okay, so there is one small equation which verifies the inverse of any matrix. So that is A inverse equals to adjoint of A divided by determinant of A. Whenever we need to find the inverse of any matrix or any determinant, we can just simply find the adjoint of that matrix and then determinant of that matrix, and when we divide both the term, we get the inverse of the matrix. Suppose, let's take an example. A matrix is given, that is A 1 3 7 8. A matrix is given 1 3 7 8. We need to find that inverse of A. So before finding A inverse, we need to find adjoint of A. So what is adjoint of A? That is A11, A12, A21 or A22. We can simply say the transpose of cofactor. Cofactor A11, A12, A21, A22, and when we transpose, what we get? A11, A12, A21, A2. Clear? Now, if we find the A11, what we get? A11 means first row and first column height, that is A, and minus 1 to the power 1 plus 1, that is 8. A12 minus 1 to the power 1 plus 2, 1 2. First row, second column, that is 7. Minus 7. A 2 A21. Second row, first column, 3. And A 2 1. So we get 1. So the adjoint is adjoint of A equals to 8 minus 7 minus 3 and 1. Now what we need? Determinant of A, 1 into 8, that is 8 minus 7 into 3, 21. 8 minus 21, that is minus 30. Now we have adjoint of A, we have determinant of A, and if we find the A inverse, so A inverse is 1 upon determinant of A, that is 1 upon 30 into 8 minus 3 minus 7 and 1. This is the required answer for this question. I hope it is clear to all of you. Now please pause the video to note it down. Now moving towards our next topic, that is properties of determinant. There are some properties of determinants which makes unique these determinants from the matrices. कुछ प्रॉपर्टीज हैं जो डिटरमिनेंट को मैट्रिसेस से थोड़ा सा डिफरेंट कर देती हैं, जो सिर्फ डिटरमिनेंट्स पे वैलिड है जबकि मैट्रिसेस पे कुछ डिफरेंट वर्क फॉलो करता है. फॉर एग्जांपल, देयर वाज वन प्रॉपर्टी इन मैट्रिसेस, whenever we are going to multiply any scalar number in matrices, then it will be multiplied in each and every component of the matrices. But here property will be different. it will be multiplied either in one row or in any column. Okay, we will see. So we will start from first property. Our first property is, if any row and any column, I can write it here, if any row or any column have each component as 0, then determinant of that matrices will also 0. It means if any matrices have any row or any column 0, then that matrix, then the determinant of that matrices will be 0. Means किसी भी मैट्रिक्स की या किसी भी डिटरमिनेंट की अगर कोई एक रो या कॉलम 0 है, कोई भी एक रो, आइदर फर्स्ट रो और सेकंड और थर्ड, or first column or second column or third column, any one, then we will consider that the determinant of that matrices will be 0. This is our property number first. Now property number 2, if rows and columns are interchanged with each other, then there will be no change in determinant. Suppose a matrix is given, that is A, B, C, D, E, F, G, H, I. Okay, we will convert this matrix in determinant. A determinant is given, that is delta. If we write this as A, B, C, D, E, F, G, H, I, means if we transpose this determinant in this, then it also gives the same value as it gives. Means suppose if this determinant gives any value 5, then it also gives the value 5. If it gives minus 10, then this also gives minus 10. Okay, it means the overall conclusion for this property is, whenever all the elements and all the columns are interchanged with each other, means when all the row becomes column and the column becomes row, then it will be always equal in terms of determinant. Whenever we find the determinant of these two matrices, we always find the same value. I hope it is clear to all of you. Now moving towards the third property, if any two rows or columns are interchanged then, okay, we can say this theta 1 theta. Then if any two rows and or columns are interchanged, then the value of determinant will be same but sign changes. Let's take an example. This time we are taking an example in terms of number. Suppose a determinant is given 1, 2, 3, 4, 5, 6, 8, 9, 3. Okay, if we solve this determinant, what we get? 1, 5 3 is 15 minus 9 6 is 54. 15 minus 54, that is 39. Minus 9. Minus 2, if we solve this, 4 3 is 12 minus 8 6 is 48. 4 3 is 12 minus 48 minus 36 plus 3, 9 4 is 36 minus 40, that is minus 4, minus 39 plus 72 minus 12, so it will become 39 plus 12 51, 121. Okay, now if we transpose, if we interchange any two rows or any two column, suppose we will do theta in delta 2, 4 5 6, 1 2 3, 8 9 3. Then if we compare the value of both the delta, then what we get? Delta 1 is always equals with, if we solve this determinant, we will get that is minus 21. Here it is 21, it is minus 21. The values are same but sign is different. Here it shows positive sign, here it shows negative sign, but both the values are accurately same. This is our property number 3. Clear? Now moving towards our next property, that is property number 4. If any two rows or columns are identical in a matrix, then determinant of that matrix will be 0. Means when any two rows or any two columns are identical, for example, a delta is given A B C D E F. Here two rows are identical, then we can simply say the determinant of this is 0. Clear? Now moving towards the next property, that is property number 5. Property number 5 is, if any constant is multiplied in any determinant, then it will only multiply with either any one row or any one column. Let's take an example. Suppose a determinant is given It is A, B, C, D. Now we need to find that K delta, means we need to multiply K. So we can either multiply this K in any of the row or any column. So we can either write KA, KB, CD, or we can write AB, KC, KD, or we can write KA, KC, BD, and we can also write AC, KB, KD. Whenever we solve this, we always get the same value of that determinant. This is our property number 5. Now, moving towards next, that is our property number 6. Our sixth property is, if each constituent contains two elements in any row or column, then we can express that determinant in, we can express the determinant as a sum of two determinants. If each constituents, okay, if each constituent contains two elements in any row or column, then we can express that determinant as a sum of two determinants. Suppose a determinant is given A plus B, C plus D, E plus F, G, H, I, J, K, L. Here, each constituent of any row is written in two terms or two elements, sum of two elements. So we can express this as a G, J, C, H, K, E, I, L plus B, D, F, G, H, I, J, K, L. The value for this term and this term will be same. So these are the basic properties of the determinants. So now the rest application part is left. So it will be covered in our next video. So that's all for this video. Thank you.